Hello everyone, this is Guru Prasan K from 3D Fully Design. 3D modeling of wooden bench. This was one of my old YouTube content. This is a teak wood bench and approx weight is 12 kg. Here I would like to explore a quick load analysis, or in other words, finite element analysis for this wooden bench.
Overall dimensions of the teak wood bench in mm. Wooden thickness is 30 mm each. The ultimate teak wood bench is here. This is a 3 disjoint piece wooden bench. We do 2D and 3D trainings for students. Let's begin the load or stress analysis or FEA on this wooden bench. Let's reckon 3 men were sitting on this bench. 3 men were sitting on this bench, viewing from different angles. Let's assume the weights of 3 men sitting. Man 1 72 kg, Man 2 74 kg, Man 3 77 kg. The general men seating sizes and measurements for to consider here. Sketched to make 3 equal partitions on the bench top for 3 men to sit with enough spacing. Splitted the bench top faces equally at 3 places for 3 men to sit by using previous sketches and applied different color. The material of construction is teak wood. Bench is with 3 disjoint pieces with bonded joints. Approx weight is 12 kg. The material properties for teak wood with their values and units is mentioned. Elastic modulus, Poisson's ratio, mass density, tensile strength, yield strength, and this is a orthotropic material. The 3 important properties for FEA: elastic modulus, mass density, and yield strength with their values and units for the teak wood. Material defined for 3 disjoint pieces, that is teak wood, and contacts defined for 3 disjoint pieces, that is bonded. Selected total 4 faces, that is 2 bottom faces each from 2 legs of the bench, which makes the grounding as fixtures. Next, applied loads at 3 split faces where 3 men sits on the bench. Let's look at the definition of these 3 loads or forces. Applied a force of 706.3 Newton or 72 kg where man 1 sits in the downward direction. Similarly, applied a force of 725.9 Newton or 74 kg where man 2 sits in the downward direction, and applied a force of 755.3 Newton or 77 kg where man 3 sits in the downward direction. Let's begin the finite element process, that is meshing the model. It's also termed as discretization. The whole bench is meshed now. Let's view the generated meshing of the bench closely on all of its portions by zooming and rotating the model. The meshing is done. Let's run the linear static analysis on this wooden bench. The static analysis ran, and let's look at the results. The von Mises stress chart is displayed. Maximum stress found in the design is 5.62 megapascal. Let's play the stress animation. Now it is playing linear static stress animation, but this is not to true scale. This is an exaggerated one. In real world we couldn't see this. Next, let's view the displacement plot. The maximum displacement found is 4.39 mm at the center of the bench. Now it's playing the displacement animation, but this animation is currently running in true scale. Next, let's view the strain plot. The maximum strain found is 0.000456 and it's playing the true scale strain animation. And ultimately, the factor of safety plot is here. The minimum FOS found in the design is 10.6, which indicates this bench design is over safe for the applied loads. So, in conclusion, this teak wood bench will bear the loads of 3 men sitting without any issues. My 3D certifications. I do workshop based 3D trainings for students. Please subscribe 3D Fully Design.